everybody. Thank you for coming. I'm Richard Millen. I'm a real estate developer at Mock Club. And Mock Club is an online retailer who specializes in vintage-inspired clothing and accessories. Currently, I'm the lead of the team that builds internal tools to manage the supply chain. And we have many systems that work together and deal with a lot of complexity. Mock Club has been growing so fast in the last few years that after some point, we realized that we had to revisit our architecture. So we started investigating into service-oriented architectures, and at that point, it was really new to us. But right now, we have a much better understanding on how to make it work. So application complexity is a really, really broad topic. So I'm just going to cover a few points that I think are going to really help you whenever you want to simplify your own systems. Maybe you're working with a really large monolithic application, and it is becoming increasingly difficult to keep it organized. Or you have decided to break it up into multiple components, but you're not sure how to accomplish it successfully. For example, at Mock Club, we have a lot of applications. But our main one, it is the oldest one, and it is huge. That's the one that is responsible for almost everything at mockclub.com. Plus, also, it includes many internal tools that we use to manage our store. Also, we have tons and tons of reports. And what you see here is probably even less than half of its functionality.
Did you start the screen recording?
Yes, I did. So at the beginning, we thought that our problem was that we were not running the latest version of Rails. But the more we thought about it, it became obvious that our problem was this really large application. So what is the problem? Working with a really large application is really hard. There's so much complexity because there are so many dependencies between all the different components. And this makes it really likely to have very highly coupled code. So every time we make any change, we have to be really, really careful not to break anything. So even if when the change is very small, and most of the code is not even modified, it is still necessary to run the whole test suite. And for a monolithic application, it takes about an hour. For that reason, I always love working with newer, smaller applications. At least for me, I feel I'm most productive at the beginning of the project. And then you wish it was always like that. Well, the solution is simple. We just need to maintain a lot of small applications that work well together. But how do we make them work well together? This can also be very messy because all the components need to be interconnected. Having a distributed architecture doesn't necessarily make your code any simpler. It can make your application more complex. For example, what happens when multiple applications need to work with the same data? What is the primary source of truth? And do you really need to make a network call every time that you need a resource from another web service? And what happens when the communication between any of the different components is down? We certainly don't want to build a system that requires all of its components to be available at all times. Otherwise, we're going to end up with a system that is more brittle and with more points of failure than having our monolithic application. As you can see, building a distributed architecture is not trivial. There are a lot of complexities that come with it. But once you get past building the foundation, all these complexities are going to look small compared to building and working with a large application. So is there a secret sauce to make it work? There are a lot of really good solutions, but for me it was understanding how messaging queues work. Of course, the architecture is going to vary depending on the needs of your company. So when we use a messaging queue, it becomes a glue between all the different components. And it allows us to have many small applications that work well together. The previous series of talks had a really good introduction about messaging queues, so I'm not going to go really deep in explaining what they are. But here are the basics in case you missed it. So a publisher broadcasts a message to all the subscribers. And anybody that cares about that message. But rather than sending this message directly to them, it uses an exchange, which itself uses queues, to store all the messages while they get delivered. And this is key. With this, we just solve part of our availability problem. We don't need to worry that an external system is not going to be notified while it's unavailable. So once it comes back online, it's going to receive all the messages it missed. So what makes an application complex and difficult to manage? I believe it's mostly about highly coupled code that knows way too much about the whole environment. So every time you write any piece of code, really think about what is the responsibility of that component and try to stay with that. Anything further, just broadcast a message. And there will be other applications and services that are interested in that particular action. So just let them do that. Also try to keep every single component as independent as possible and cache as much information as it makes sense. This way you will not depend on the availability of additional services. So rather than calling a RESTful API every time that you, on every request, just use your favorite key value store, a relational database, or a search engine like Solr to keep all the information that you care about stored locally. So in all these cases, you will update the cache when you receive messages indicating that the resource has been updated. So right now we just solved two problems. First, we removed the latency during a request by not using external services, and we're now able to easily join information between many systems because, like for example, if we use a relational database, we can continue using SQL joins. So let's go over an example. Let's say that we need to create an online store and sell physical products, pretty much like Makla. It's super simple. Basically, we just have to sell products and send them to the customer. That's pretty much it, right? Well, not really. There are other actions that need to happen after the order is placed. First, we need to mark the order as completed. We need to decrement the inventories. We need to notify our customers with an email. And probably we need to create a big ticket that is going to be used at the warehouse. Also, if we use caching in our site, we might need to expire it because maybe the product is not available anymore. And we need to change the product's badge to sold out. And maybe our finance team just requested that they want a transaction log added to the database after a product is sold. And I could go on and on with other actions that need to happen after a product is sold, but I think you're getting the idea with this. So if we put all this code in a single location and execute it all sequentially, we're going to end up with code responsible for knowing the whole workflow about the product sale. And it is really not the order's responsibility to do all this. I think this might be okay if you have a really, really small project, but it's going to get really complex very quickly. And it's not going to be very scalable when you have many teams, and every team has different responsibilities, and everybody's touching the same code base. So let's simplify this a little bit. So now imagine that the code responsible for completing the order only needed to mark it as completed. And that's it. It is really not the responsibility of the order checkout to do all the other actions that we talked about previously. So then we use our messaging queue to notify that a product has been sold. And there will be other subsystems that care about the sale of products. And each one of them is responsible for completely different actions. So the finance team, they can have the logging they need. And we can add an inventory service that can decrement the available units. And by doing this, we achieve something really big. And it's that we don't have to do it for them, because every system just did it by themselves. You have the finance team that did it by themselves and the other service as well. So then let's go back to our example. So then if the inventory system detects that a product is no longer available after a sale, it can send a product sold out message. And our catalog is interested in that message. So when it gets it, it will expire some caches. And it can regenerate, like for example, the products batch to indicate that the product is sold. So this made it a lot cleaner, right? Well, there's a huge reason why messaging queues have become very, very popular lately. And to be honest, I didn't really see the benefit of distributed architectures till I started working with messaging queues. And I thought that distributed systems were more complexities than benefits. So I hope that this example makes it simpler for you. So let's continue with our example. Who owns the inventory information? And what happens when a product is returned or a product is found defective and needs to be taken out of inventory? Certainly the store is not the only application that cares about inventories, because it's not its core responsibility to keep how many products are available on stock. So if we take this responsibility out of the store, should we really call an inventory service every time that we want to render a catalog page? And even like do we need to check the inventory whenever we want to complete an order? We certainly want to show accurate information to our customers, but we should always try to avoid external dependencies whenever working with distributed systems. So remember that I suggested to use caching as much as possible. Well, let's apply it to our inventories. So if we cache all the products that are available in our store, let's say we can use something like Redis for this. When a product is sold, we can quickly decrement the values. So let's say that we have 5 products available and we sell 1. It's not really hard to estimate how many products we're going to have available after the sale is done. Can you guess? It's going to be 4, right? It's not very hard. So after that, the store will notify that it made a sale, and the inventories service can decrement the global value of inventories. So then after that, the inventory service can broadcast that the inventories for that product have been updated. And since our store is subscribed to inventory adjustments, it can keep track of how many products are available, even if other systems are modifying the inventories. And by doing this, we basically took all the code responsible for managing inventories out of our store, and we moved it to the inventory service. And now we don't even rely on the availability of our inventory service to complete the order. I strongly believe that no single component should own a message. You really want to be able to shift application responsibilities around. And other components shouldn't really care who is doing what. So whenever you add a message type, just think about what is within your whole system where it belongs. So if you're using Rails, it's very easy to accomplish it by adding a gem that can abstract the communication between your application and the messaging queue. And it also is going to define all the requirements of all the messages. And this is also an easy way to document all the messages that are available for both publishers and subscribers. If you're not convinced yet, I have 3 more benefits. So 1, you're going to have fast and simpler tests. Why? Because you're going to have less files per component. Also, you're going to have a smaller memory footprint. So every component is going to use less memory, so you're going to, the benefit? You're going to be able to put more instances per server. And also, since you're going to have less files per component, it's going to be a lot easier for you to find where you have to change. This is an overview of how a messaging queue can fit within your infrastructure. So a web app can talk either directly to a messaging queue or a RESTful API. I would recommend trying to talk to a messaging queue as much as possible, but sometimes you need a response, so in that case you will call the RESTful API. Also, like Rails itself cannot be subscribing to the messaging queue, so probably you are going to add something like an event daemon that is going to be listening for this messages. And it's going to translate the messages into actions. And we're going to use something like rescue to queue all these jobs, so then some workers can take care of them. So remember this, to avoid complexity, each component should be as independent as possible and have a very defined responsibility, and know as little as possible about the rest of the infrastructure. It shouldn't really care who does what. It should only care that another piece of the infrastructure is going to take care of certain actions that it cares about. and that it is going to be notified when it is its turn to do something. Thanks.